Greetings, coders. In this video, we're going to look at arrays in C. Arrays in C aren't really that different than what you're used to with Java. So what is an array? It's basically just a section of memory that is allocated to store values. And we're able to use operators to access the memory because it's contiguous like that. It can be based on mathematical calculation. Any array in C must have a size associated with it, and that size can be dictated by the declaration of the variable or by the definition when a value is set to it. We'll see how that works in a second. And the size may also be determined at runtime, so you could perhaps calculate something and then put the size in there at runtime. So here's an example of an array definition that also includes its values. And we can see that you have the 8 for the number of slots that it'll have. And then we have gone ahead and initialized 6, 1, 2, 3, 4, 7 of the slots. So there's still one available slot over here that's uninitialized. Now let's look at how this looks in memory. With an int, that means that each of the array slots are going to be 4 bytes because an int in the version of C that we're using will be 4 bytes. We can see starting from 0 that these values are added to memory in bytes of 4, just like that. Looking at the print statement down here, we can see that numbers, we're accessing the third location in the array. So we've got 0, 1, 2, 3. It's accessing this value. And that is right here in memory. So behind the scenes, the 3 is being actually converted to 12. Take 3 times 4 for the size of each location in memory. And we started off at this value, and 1C is an offset of 12 from there. Now, with a character array, we have changed that each one of the array locations, they're still contiguous, but now the difference between each array location is just 1 byte instead of 4 bytes. So when we access at letters 4 here, we are accessing the 0, 1, 2, 3, 4, fifth position. But instead of multiplying it by 4 like we did in the past one, it's not 16 bytes away. It's only 4 bytes away because each array element is just a single character. And so we end up with numbers 4 at array location or at a memory address of 14. Now to iterate through an array, this array example, we can do a for loop where the I is less than 8, and we'll iterate through each one, and using printf with the %c, we will print out each letter on its own line. And as we go through and increment I each time, so now I is equal to 1, we're accessing B, and then C, then D, E, F, G, and then we've set the value to less than 8, so it will still actually print this value even though there's junk in there. Something to note why. Just because the value up here was set to 8, we may not want to use that for the array because we don't have the array completely filled out. We only have 7 items in the array. And that's it for this video.